Hey folks, Kevin here. Well, it's February 14th, 2019. I'm in the lower, most northern shop again. And recently I talked about getting insulation, the polyisocyanurate, up in between the floor joists up here on this wall partition. And I needed to cut more pieces of insulation for filling up the spaces between the studs. So those are 2x6 studs that are 16 inches on center, and I use three layers of polyisocyanurate 1.5 inches thick to fit in there. And one of the things that I guess an important point that I wanted to make was that I'm using all of these scrap pieces from all the other building projects. Now, all of this insulation, including the 4x8 sheets that I'm using, are all recycled insulation. It came from a high school, I believe in Herkimer, where the construction crew carefully took this out, brought it to their homes, and then ended up putting it on Craigslist. I bought a whole bunch of it. I insulated the chicken coop, the work area, the attachment to the greenhouse, the sugar shack, the root cellar, and now I'm working in here in the workshop. I don't have a lot of it left, but during the first video of the series working in here in the workshop, you could see big piles, and I didn't show all the piles because this whole corner here you couldn't walk through, and it would go all the way around up the wall about midway up there with all of the partial sheets. So when you're cutting in around some of these hip roofs and all, you have lots of different angles and pieces that are left over. And so I had tons of pieces that I knew I wanted to reuse, and I used up all the larger sheet pieces initially. And recently I've been using pieces that are even just 3/4 of an inch thick, 3/4 by 1.5, because the thickness of the insulation board is 1.5 inches. And I build up these layers in between. I packed them in really firmly with a hammer and a board to make sure that I was creating a good thermal barrier. So that's point one that I wanted to make, was there's still lots of these small pieces, and now I'm up working in the above the floor joists. Let me walk over there real quick. So right above my head, there's all those pieces that you see that are end on. They're actually pieces of polyisocyanurate, and this is the size that I'm cutting them down. So that's a 2x6 wall, so it's 5.5 inches deep, but 7.25 inches tall. So I'm taking all those scrap pieces and cutting them down, and then packing them in there very tightly, using a hammer and boards to get a nice air barrier as well. And so that brings up the next point. So I've got a lot more work to do with this. Jesus, probably 2 months ago, my nephew Jim I think he sent me a text or an email saying, hey, whereabouts is your video on barriers and how to put them in? And because I'm not very well organized with this YouTube channel, I didn't know where it was either. I didn't label it correctly. So someday I'm going to learn how to do these YouTube videos better, so it'd be easier access for everybody to be able to go ahead and do an easy search for them. But so the vapor barrier, the simple, straightforward answer is, in a very cold, temperate climate like this, you always want to have your vapor barrier on the warm side of the building. So we're in a cold, temperate climate. There's high humidity and warmth inside of the buildings, and therefore you want to put that on the inside to prevent moisture from getting down into the walls. I'll do another video about all the barriers because I've talked about thermal bridging. So all of these studs, these 2x6 studs, now this is holding up a big beam up above up there, but all these studs, 1.5 inches thick, are conducting heat energy through those boards. much less heat energy is being transferred through the insulation, especially the thicker the insulation. But this is what I refer to as thermal bridging. And so how do we prevent thermal bridging? Well, we put a barrier. So we're going to be putting insulation, another sheet, right up against all of this. It won't be as thick as the 4.5 inches in between the studs, but it will be enough of a barrier that really will make this environment much more comfortable to work in and much more energy efficient. So I talked about thermal bridging and thermal barriers. Well, there's really 4 types of barriers whenever we're doing new construction or remodeling. Certainly, most people are familiar with vapor barriers, and that goes on the warm side. So if you live down south, you may want to be putting a vapor barrier on the outside. I'm not so certain about it. There's a lot of literature about that, so I'm not positive that that's the best thing to do. But up here in a really cold climate where we have high humidity in the Great Lakes, we have all this cloud cover, we have rain, we have lots of snow, there's plants inside our homes, there's animals inside our homes, we're all exhaling high moisture content. Well, we want to have a vapor barrier as well, and that goes on the inside of the house. But what are the other barriers? Well, certainly we've talked about thermal barriers. So we really want to have insulation covering every inch as much as possible. We need to have a rain or water barrier, so that stuff that comes off the eave of your house hits the ground and splashes up on the siding, or that wind-driven rain that smashes up against your house and potentially goes in around your windows. Well, that can create mold and decomposition of the woody materials that are there as well, and make the environment unsafe to live in. So those are rain barriers, vapor barriers, and thermal barriers. But probably the one that people don't get right very often at all is the air barriers. And that's when we're talking about having tight homes. And our house is pretty darn tight. We did all the taping and sealing with 2 layers of 6 mil polyethylene when we built the whole system. And you can feel it when a door or a window closes. We've adjusted things with our cool air intake and the doggy door, those things there, but it's still a pretty darn tight house. So air barriers, so every time that there's a penetration, so one of the things I've been talking about is I pulled all the wires that were within the studs. I had tons of wires going overhead. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 inch, 1 inch in diameter holes that go through the floor joists, and all of those wires went through the top plates and down these walls or up the walls going up to the 2nd floor. And those are all conduits for air. When you have any sort of non-insulated material penetrating the wall. So in this shop, I'm going to have a compressor on the other side, and that hose over there is going to feed compressed air into here. So ideally, we want to make sure we seal around it. Every wire or electrical service, network service, monitoring, surveillance system, security with your alarm system, all of those wires need to be sealed around the wires that penetrate. Often people will have in their top plates going between floors, there'll be holes there that haven't been sealed, especially those ones that go up to the attic. If you have insulation in the floor, in the ceiling joists, where the attic's above that area, and then you have these penetrations, well, air leaks through those areas. So a lot of air can leak through a really tiny place in a non-airtight home. And what goes through besides the air is the high humidity that works into that area. And if it gets trapped inside, well, that's going to create an ideal location for mold and destruction, loss of efficiency of some insulations as well, and breakdown of wood as well. So I guess I'm gonna not make this video much longer, but the four barriers we have to think about whenever we're looking at a house to purchase, when we're building a new place, or when we're renovating the place is the four barriers: thermal barriers, rain barriers, vapor barriers, and certainly air barriers. Because if we don't really make sure those air barriers are taken care of well enough, that's also a hole in our vapor barrier. That's also a hole in our thermal barrier as well. And if it goes to the outside, it could be access and entrance for rain as well. So I think that's about all I wanted to say for today's video. If you have any comments or questions, please leave them below. I'm not an expert in this area. This is just something that when I look around and I see what other people are doing with their construction techniques, it raises concern on my part. And so knowing the materials that you're working with, that's really beneficial. And knowing what penetrations there are, where everything's going. So if you have comments or questions, please leave them below. Please give us a thumbs up if you thought this video was of value. Share it with your friends. Hit that bell icon if you'd like to be notified when we post more videos. And subscribe if you haven't subscribed. That can help the channel out as well. Thanks so much for watching, folks, and have a great day. Bye-bye now.